So you think you're a functions hotshot. You can define a function. You can define a function called kittens that calculates the number of kittens that you have. Maybe it's, I don't know what would be dependent on how many cats you own or time, whatever. And we get some tool that we can use. That's kind of the purpose of a function, is creating little mini tools, and those tools can combine together, and you can use them to do neat things. Like if we were to run this and I wanted to evaluate kittens at 3, we're basically getting 2 to the power of 3. It's our own little mini calculator that we get to design ourselves, and we get 8. Neat. And you can do other things in Python too, where we define another function, and it could be named anything, and we could take anything as its input. Like these words don't really matter, unless like you're trying to communicate with other engineers and really say what you're trying to represent. We could take whatever number we want and add 3 to that number. So if we do pups at 5, we should get 8 as our output, because 5 plus 3 is 8. If we did kittens at 5, we would get a totally different output, 2 to the power of 5, 32. Cool thing you can do with functions is also mix and mash them. So we could calculate kittens at, I don't know, whatever number you want, -2 plus pups at, I don't know, 0. And we could run this. I put it in a print statement. So it's calculating kittens at -2, so 2 to the power of -2. And then we're adding 3 to it. So a quarter plus 0, a quarter plus 3 makes 3.25. Point is, we can mix and mash these functions together, and we could go even further and put a function inside of another function. So we could look at kittens that takes pups as its input, and inside of pups we can put 2. So what we're essentially doing here is evaluating pups at 2, which is 5, because 2 plus 3 is 5. And then whatever that output is, which is 5, we're putting it as the input for kittens. And we get 2 to the power of 5, we should get 32. All right, cool stuff. Now this is all in good, but you came here for anonymous functions. You came here to understand what the heck Lambda is and why you even use it. What's the point? Sometimes I saw some videos where I say this is totally useless, you shouldn't worry about it. And I wholeheartedly disagree, because it's really useful. You can define a function that doesn't depend on other functions to be defined, even though in its own definition it requires other functions. And I'll show you what I mean by this. Let's come back to calculus or pre-calculus, where you look at this idea of instantaneous rate of change. And I'm going to create a function called iroc. And this idea, I'm going to skip the part where we look at the inputs for this function and kind of go straight to the definition you've probably seen before, which we're going to wrap the numerator in brackets. And that's f at x plus h minus f of x all entirely divided by h. So we've got a little nudge in the y where we're looking at the difference, the change in y over this change in x, which is h. But this function needs another function to survive. So we can actually pass functions through. We define this function privately to iroc as f, and we need that x value, we're trying to center it around. And we also need the h value to know how much we're nudging. And we can do a cool thing with this. I'll wrap it in a print statement. We can take either one of our previously defined functions, like kittens, as our input. We can pass, well, let's look at 2, and we can define an h value. So essentially it's looking at a exponential function centered around 2 with a very small step value of 0.01. And we get this 2.78. And if we get this h value smaller and smaller, we're getting closer and closer to our real answer, 2.77. Yeah. It's kind of exciting because, well, we're seeing we can define a function by another function, but the unfortunate part about this is what if we don't have access to other functions? What if I don't have access to kittens? Well, this whole thing breaks, right? What do I do to put a function inside of here that I want? You know, something that's flexible, something where I don't have to define kittens in advance, and I can just put it directly into the function itself. Well, that's where Lambda comes in. So we had iroc being defined as requiring a function, and I want to pass my own function in when I want to calculate iroc, instantaneous rate of change. And we can do something like lambda x and 2 to the power of x. And we're going to get the exact same thing that we had earlier. The beauty of this is every single time we want to pass through this function, or sorry, every single time we want to evaluate the instantaneous rate of change, we can now do it with whatever function we want at this time. And I'll show you with with the sine function. So let's say I want to see this, but with sine. Oh. What am I doing? Okay, that's a bit better. Undefined name sine. Oh yeah, I'm just going to import math. Okay, cool. So we can pass through a sine function through here. We can even get wild with this and, you know, do a sine plus a cubic or sine plus linear, whatever you want to do. And we can find the instantaneous rate of change centered around 2. No matter what function we can play, we could send around 5. We can get wild. And we can do math.pi. You know, what's the rate of change going to look like at pi? Easy peasy. And, you know, it's a way where we can pass through a function without having to define it ahead of time. And that's the big idea behind Lambda and anonymous functions.